Hey, Chad, the AHA company, talking today about verified stellar sources. Let's start with the stellar blockchain. All right, and we've got a smart contract deployed on the stellar blockchain called Registry. Registry is basically this smart contract plus some other fancy stuff. So, what does that contract do? Say you add another contract, a WASM to the blockchain. You upload a WASM. That's the little elephant here. A WASM, of course, is identified by a WASM hash, 85D8EF, and some behavior defined in the WASM blob itself. So this is the key for it on chain, is the hash, and this is the behavior. Great. Stellar Registry is a way, it's again a contract, so it's identified by a contract ID, not a hash. This one is CAXJET. And Stellar Registry stores that WASM hash 85D80F and gives it a name, guess the number, and a version 001 in this case. Cool. All right, so with an upcoming SEP, you are able to add some extra data to the WASM blob when you upload it, like the repo, the ahako/scaffold stellar, and the image that you use to build it, stellar/stellar CLI. That's on Docker Hub. All right. If you forgot to upload it there, or if you change it later and you don't want to upload a new WASM blob, you could also add that information to Stellar Registry itself. So Stellar Registry, first of all, is a place to surface this information, to update it after the fact. So all of the WASMs that are already uploaded on chain can have this information added. Cool. But you can lie. You can say whatever you want in there, right? So there needs to be some way to verify these stellar sources and say, does this, if you pull this repo at the version also specified in the metadata, and you build it with this image, does it actually match this hash? Okay, so how's that work? Well, when a WASM is uploaded, it emits an event with a WASM hash, repo, and image. Or if you add that build info to Stellar Registry, that emits an event too. And that's going to go over to a verification service. These are going to be run by multiple companies. There's going to be many verification services. Oh, that's too stuck. There we go. And so they ingest these events and they do some processing and they say verification, runtime verification. Say this one is from runtime verification. And they say the result is true. The WASM hash, repo, and image all match. Cool. So we store that in the registry. This information is also ingested by another source verification service like SourceProof, say. And what if they disagree? What if they say, no, that does not match those WASM hash, repo, and images? Well, now we go back. Let's get rid of the verification services. By the way, we are working with runtime verification to launch an initial runtime source verification service for verified stellar sources. All right. So when that information comes back, when those verifications are added, that also emits an event. And the other piece of infrastructure here that we AHA are going to build and maintain, we already have a indexer. So these get ingested by the indexer, and then they all get like aggregated into a nice result served over an API. And anyone could build a similar service, right? And so this API endpoint is just going to say, this hash, 85D80F, you better be careful. They do not match, and you can get all the details for what exactly went wrong there. So it surfaces disagreement rather than collapsing it. And if you want to create your own policy for reading these and say, give me everything that's trusted by runtime verification, then this one would return clean, right? Sure, it's trusted by runtime verification. Or if you want to apply some other policy, you, the consumer of this information, decide that your trust policy at the time that you read it. So that is verified stellar sources in a nutshell. Check out the full architecture diagram for more information about all those different pieces. Thanks. Catch you next time.